Okay, right, you two, is it phrased correctly? Zoe.
Yes,
Thank you.
Can I start?
Yes.
Okay. Grade 11, choice 1, the 23rd of June, first half hour.
And
Action!
you're boring. Isabella gives me a whole spiel there. Okay. All right, here we go. So what we're going to look at first of all is we're going to look at a movie of a brain dissection. It's a,
This is a pig's brain, but this is going to help us to learn a little bit more about our own brain. So one of the most recognizable things we see about the brain are these little kind of grooves and bumps that we have. So the little grooves, these are called the sulci, and the bumps are the gyri. And this helps to increase the surface area. A pig's brain doesn't have quite as many grooves and bumps as our brain would do. In fact, for our brain, about 2/3 of this surface is hidden inside those grooves. This gives us a bigger surface area, so it allows us to have more neurons, more brain cells. Okay, so here we can see the brainstem. So this is where all of our nerve signals are coming into our brain from all around our body. And as we go up here, we come to what's called the cerebellum, which literally means the small brain, the little brain. And this is responsible for things that need sort of very precision timing. And then we come up to the main part of the brain itself. We have the cerebral cortex here across the whole of this. And this is called the cerebrum. If we look just over here, you can see this little bit of black stuff there. The arachnoid mater is part of the meninges, which is a set of coverings that protect our brain. It's actually the meninges that get inflamed with the illness meningitis. Our brains are split into two halves or hemispheres. So we have the left-hand one and the right-hand one. And actually your left-hand hemisphere of your brain controls the right-hand side of the body, and the right-hand side controls the left-hand side of your body. There is bits in between them though, so that the two hemispheres can communicate. This is called the Corpus Callosum. So let's have a look at our pig's brain and see if we can find that. So this one's already been cut in half. The Corpus Callosum is this little structure that we can see in here. That's connecting the two hemispheres of our brain so they can communicate. So you might have heard of grey matter and white matter in brains. So I can show you what that is. The white matter is this, it's actually kind of light pinkish stuff here, and the grey matter is the darker pink bits around the edge. And these are actually different parts of our neurons, our brain cells. So we have the cell bodies, and these make up the grey matter around the edge. And then our neurons have a long thin bit, it's called the axon, that has a layer of fat all the way around. And those come in and give us our white matter. It's actually that fat that gives it this light pink colour. That fat's helping the messages to go through our neurons and to help them to protect them. So when it comes to brains, does size matter? Well, if you look at our pig's brain, this is quite small. It fits easily in the palm of my hand. The largest brain in the animal kingdom belongs to the sperm whale. My brain is probably about the size of my two fists together like this. They're not even close to the size of the sperm whale's brain, and I thought that I was quite smart. I've got 86 billion neurons in there. So perhaps it's brain size compared to body size that matters. As animals get larger, in general, they have larger brains. But humans have the largest brain size to body size ratio of any animal.
If you'd like to see more insights on the outside, check out our heart and eyeball dissections. Coming soon, we'll be dissecting an egg in our hatchery. So for more science,
Alright, so that was quite nice and simple. The only thing that they give a name to the folds and the grooves. Okay, so sulci and gyrus, and don't obsess about that. I'm going to show you another more detailed, but only because this shows certain things that the other one doesn't show. There are going to be parts in this one that are too detailed for you, and I will indicate those parts that are too detailed. Okay.
Neuroanatomy Laboratory. We're going to go inside and do some dissections of the brain and look at some of the important structures that are useful for understanding neurological principles and localization. The purpose of neuroanatomy and all of its tortuous tracks is to allow you to do neurological localization. That is to say, decide where in the brain of your patient the disease process is occurring. That's the total reason for most of you to want to understand the connectivity of the brain. Now let's look at the surface of the brain. We've removed the coverings, the leptomeninges, the pia, and the arachnoid, and I wanted to show you the different lobes of the brain as an introduction. In addition, on this brain, you can see the brainstem. The brainstem extends from this region where my probe is, a little bit difficult to see, down all the way here to where the spinal cord was attached. In addition, you can see the cerebellum, involved with coordinated motor control, as well as the surface of the cerebral cortex. This is the ventral surface of the brain. And the most prominent feature here is the temporal lobe, which I am outlining. Here is the temporal lobe on the other side. And in front of it is the undersurface of the frontal lobe. Cranial nerves are attached, such as the visual optic nerve and the sensory nerve from the face, the trigeminal nerve, and blood vessels, such as this large basilar artery, are running on the surface. Or you can even see the large internal carotid artery. We will come back and look at the nerves and the arteries and the other connections in greater detail. But I just want to introduce you to the region of the medulla, the pons, and the midbrain. And together they make up the brain stem. Let's look at the surface now of the brain and look at the different lobes. You already saw the inferior surface of the temporal lobe coming back to here, and we just kind of arbitrarily draw a line and say that this is approximately the end of the temporal lobe posteriorly and the tip of the temporal lobe anteriorly. And then we look for a sulcus on the surface of the brain. Sulci are these grooves, and the surface structures that are coiled are the gyri. So we have sulci and we have gyri. The gyri have names, but we're not going to learn most of them. However, this major sulcus, the central sulcus, because it runs from the midline all the way down to the lateral fissure, separating it from the temporal lobe, this central sulcus separates frontal lobe in front of it from parietal lobe behind it. And very interestingly, the cortex involved in voluntary movement is in front of the central sulcus, and the cortex involved with primary somatic sensation from your body is the gyrus behind the central sulcus. So this is frontal lobe, this is parietal lobe, this is motor cortex in general, and this is sensory cortex in general. So we're just getting our bearings. The frontal lobe is further sort of divided, and it's hard to see the distinction, but this band along here is the superior frontal gyrus. Then we have the middle frontal gyrus and the inferior frontal gyrus.
That you don't have to know.
The motor cortex in front of this precentral gyrus, as we call it, because it's in front of the central sulcus, is an area involved in the left hemisphere, which we're looking at, with the production of speech. And you may have heard of it before. It's called Broca's area. The rest of the frontal lobe is either motor function, planning motor function, or executive functions such as judgment and planning. Let's look at the parietal lobe now. The parietal lobe is separated from the occipital lobe by an arbitrary line that we draw between the parietal and the occipital regions, these little notches here. So if I were to display here, I would say that approximately this is the occipital lobe. The occipital lobe is very important in humans because this lobe is involved with visual information processing. It's a wonderful brain that we have, and we are very specialized as humans for visual computation or orientation and analysis. So we have our three lobes. Occipital lobe involved with vision, parietal lobe involved with sensation and integration of multiple modes of sensory input, and the frontal lobe with motor and higher order function. And this temporal lobe that is down here is very much involved with auditory information, which is coming into this fissure here that I'm pulling down. This is the lateral fissure. And auditory information, sound, comes to both hemispheres and is processed here. And this area behind it, the superior temporal gyrus, this back part here is involved in the comprehension of language. So you've got two language areas, an interpretive language area and a production language area. And when we study the consequences of cerebral stroke, we'll see that some strokes can knock out one area and you'll have problems producing intelligible speech, while other areas leave you hearing perfectly fine but not understanding what you're hearing, and other lesions or damaging strokes that involve all of this area can leave you with a large deficit, which we call global aphasia. Aphasia is a language disturbance. The temporal lobe, in addition to having an auditory function, has an area underneath this gyrus here, which is required in one hemisphere for forming new memories. It's called the hippocampus, but it's not visible here. So temporal lobe, auditory and new memories, occipital lobe, visual information processing and recognition, parietal lobe, somatic sensation from the face and the body, frontal lobe, motor execution voluntarily, planning and execution of appropriate judgment and actions. The two hemispheres are not identical, and later we'll talk about special localizations between the hemispheres, but right now I just want to point to the fact that the two hemispheres are held together by a large band of fibers called the corpus callosum. What I have here is a coronal section through the brain. What we've done is we've taken our brain and we've sliced it like through this way, and so this is called a coronal or frontal section. And I'm going to rest it here so that you can see the internal structure of the brain. We'll deal with these in more detail, but right now you can see that those gyri that we were looking at and the sulci, the dips in between, can be easily distinguished. And the gyri are covered with a nice layer, beige in color, and that is your gray matter, as we say, of the cerebral cortex. Maybe we should have called it beige matter. And beneath it is a lighter area, which we call the white matter. In general, gray matter consists of cell bodies, both neurons and glia, and white matter are axons. Axons are the processes of neurons either coming to the cerebral cortex or leaving the cerebral cortex and descending to lower brain structures. An example of white matter here is this band of fibers called the corpus callosum. It was that band that held the two hemispheres together. When we were looking down through that interhemispheric fissure, the base of that is this band of white matter connecting similar areas or homotopic areas of one hemisphere with the other. And this is a way that the right and the left hemispheres can communicate. In addition, they can communicate through structures like this deep area. You notice it's beige, so it's mainly cell bodies. A deep structure called the thalamus. And here we can see the temporal lobe that we were looking at on the surface. Notice here, if I crop this up and pull it down a little bit, you can see that large lateral fissure that we saw on the lateral surface. That means that this is the temporal lobe. You can even see a blood vessel in there. This bit of cortex buried underneath the hemispheric temporal and parietal lobes is the insula. We're not going to deal with that, but it does have a name. It's where the cortex got buried as it became more and more convoluted. This is parietal, or it could be motor cortex. Can't tell for the isolated section exactly if you're in the frontal lobe or the parietal lobe. Doesn't really matter. And remember, I told you that one of the functions of the temporal lobe, in addition to the auditory region, was an area involved in memory. That area is called the hippocampus, and it's curled up here right in this medial part of the temporal lobe. The other major structure you see in a cross-section like this, or a coronal section, are these holes in the brain. One here, one here, one here, a little bitty one here, and here. These form part of the ventricle system, which we will explore further, but right now just know that they're filled with cerebral spinal fluid. And the leptomeninges, or the pia and the arachnoid, on the surface, if we can zoom in a little bit, we can see them delicately covering the surface of the brain. The main thing I want you to see on this brain is the brainstem. So this is the cerebellum that we saw before out to the side, and the brainstem, recall, was in the middle. Here we have the brainstem on a mid-sagittal. This is cut in the middle. So this is a mid-sagittal section. Here's a bit of the medulla. Here is the pons, with a big basilar artery creeping up over it. And here is the midbrain, often hard to see. And finally, then we have deep structures such as the thalamus. And we can see many of the vessels like the anterior cerebral artery here, as well as spaces such as the ventricular system, which we'll look at in more detail.
Right. I hope they've made it more concrete for you. No? Yes? Maybe? Do you want to ask anything? Do you want to discuss anything? Are you asleep? Wheeze up! He so is asleep, little brat. Okay, Tash, I'm going to throw something at him, so best you duck. Now he's a fool. Actually, maybe not. What you want to do? Right, next year when we do adrenaline, just remember this moment. everybody 100% fine with the different parts of the brain? Alright, so on Friday I didn't write down how far we got, but I do think that we finished the hypothalamus. And the hindbrain and the cerebellum. No? Yes? Maybe? Alright, so if we look at this here, okay, we'll write with those various parts of the brain. So, what's important here is that you know that everything from here to there is cerebrum. This is cerebellum. This is the pons. This is the medulla oblongata. And there goes the spinal cord. Okay, then you need to know the corpus callosum. Then it showed very clearly in the video that you watched, the second video, that everything from here onwards is frontal. Okay, you don't have to know the names of these deep fissures. Okay, so that would be frontal, this would be parietal, that would be occipital, and then sticking out at the bottom here, but it's actually on the other side, this would be temporal. So remember, you do need to know the main parts of those different regions. So this is mainly to do with vision. This is mainly to do with interpreting sensations from the various parts of the body. There's a line down on the other side that's to do with movement. And then this is the main willpower, judgment, reasoning, etc. region. Okay. And then the temporal lobe is mainly to do with what you have to know. The temporal lobe is to do with interpreting sounds. Okay.
End of grade 11, choice 1, the first 30 minutes, 23rd of June. Cut.